Hello, this is question 2 from paper 1 from the 2018 higher level Leaving Cert Maths exam. Up the top right of the screen you'll find a playlist that'll bring you to all of my solutions to the questions in this paper. And below the video you'll find a link to an image of this question so you can do it in your own time. Part A of this question gives us three terms. It doesn't look like 3 to most people, but it gives us three terms. X squared, yes, x squared is the first term. There's a comma there. Then 5x minus 8 is the second term, and then x plus 8 is the third term. And this is three terms in a geometric series, it tells us. So there's other terms. It continues on here. These are just numbers we don't know. This is some number here in each of these sequences. And it asks us to use the common ratio to show this. Really, that's another way of saying find the common ratio. And when you're trying to do this, this equation will appear. So that's what we're going to try and do. Okay, so the common ratio is the difference, the multiplication factor between each term of a geometric series. So if you multiply the first term by something, you get this one. If you multiply this by the same thing, you get this one. So we can use that fact to find the common ratio, or really to show this we're going to do. So another way to say what I just said is divide the second by the first will give you the common ratio. 5x minus 8 divided by x squared. That's equal to the common ratio. But also, well, let me write it there, is equal to the common ratio. But it doesn't have to be the second and the first. It could be the third and the second, or the fourth and the third, any two in a row. So the third one would be x plus 8, and the third one divided by 5x minus 8. Both of these are equal to r squared. Sorry, equal to just r. So we can just ignore it there. We can say that this is equal to this one. They're both equal to r. So that's where we get an equals. That's where we get an equals with only x in them. And that's where this equation is going to come from. There's only one unknown, so we can solve this. We will be able to find out x when we solve this. But when we're trying to solve this, it should just start looking like this. So that's what we're going to do. We're just going to multiply both sides by 5x minus 8. And then we'll multiply both sides by x squared. Just get rid of the fractions. So this coming up here will give us 5x minus 8 multiplied by 5x minus 8. And this coming up here will give us x squared multiplied by x plus 8. Let's multiply that out. We'll get 25x squared here. We'll get minus 40 minus 80x from both of them. Minus 8 by this, minus 8 by that one. Minus 8 squared is plus 64. This is equal to x cubed and plus 8x squared. Get them all over the same side, and we might as well keep the x cubed positive. So we'll get everyone over the right side. We'll get x cubed. Let's see, all the x squares are 8x squared minus 25x squared. It's equal to minus 17. That's good. Minus 17x squared. Let's see, minus 80x will become plus 80x. Again, just as we hoped. And 64 will become minus 64. And we're left with just a 0 over there, so equals 0. Or I'll just write the equals 0 here. And that's it, we've shown this one. So that's all we need to do for part A. I'll continue on here because part B continues on here. Part B takes this function, calls it f, and tells us that f1, when we put 1 in for x, we'll get 0. Do they ask us to confirm that? Find another value for x. So okay, we'll believe them. We could just test it quickly, but we'll believe them. Okay, so find another value. There's a couple of ways to do this. I guess I'll show you the quickest way. First of all, we'll say if 1 fits in, that means that's a root. 1 is a root. That means x minus 1 is going to be a factor of this. So the slow way to do this, but I quite like doing it the slow way, would be, I'll write up here, would be x minus 1 divided into this function here. X cubed and blah blah blah. I don't want to write it all. Divide it in and you'll get a quadratic out. It'll go in quadratic times. X to the power 1 will go to x to the power 3, x to the power 2 times. So you'll get a quadratic out. solve that quadratic, and there's your two answers. That's one way to do it. I quite like another way. We'll leave this here, make a little more room. We'll say fx, yes, fx it is. Fx is equal to x minus 1 multiplied by two other factors. And we can say that's x. Actually, I don't really want to make up letters because I'm not going to use this way, but well, let me write in x minus a, x minus b. We might write that and solve for a and b. I don't like doing it that way fully. Actually, that's probably an okay way. I always find this quicker though. It's equal to something x squared, an x, and a number. So you might write ax squared plus bx plus c. Solve for them. Except it's not ax squared. Because I know what the answer is. I know the answer is x cubed. Well, no, I won't write it again. I don't have much room. It's equal to this. It's equal to fx. It's equal to this. So x multiplied by x squared is already equal to x cubed. So there must be a 1 there. I don't have to write a in. I've already solved for a. Plus b. Well, I'll leave it as b, although maybe it should be an a. So there's some number here. I'm not sure what that is yet. And then there's some number here. But this last one, I know this one as well. This number multiplied by this number will equal this number. So I know it must be a 64. So I can already solve a lot of this without doing any maths, just using a bit of logic. So that means this factor multiplied with this factor will equal this. I still don't have to do all the maths. It's a very short way. I still don't have to do the maths. I just have to use b a couple of times. So, well, how to say this? I need to complete one of these. I know this number is 1. I know this number is minus 17. I know it's 80, and I know it's 64. I just need to use the fact that I know all of, say, x squared. Let's pick x squared here. I'll get all the x squares that appear out of here, and I'll solve for b. Let me show you what I mean. The only way I can get x squared would be minus 1 by x squared. Sorry, minus x squared, that'll be. X by this x, that's plus bx squared. And that's it. That's the only way to get it from here. And I know the answer has to be minus 17 x squared. I know there's minus 17 of them. So what is b? Well, it's quite obvious that b is equal to minus 16. That's it. We're done. That's all the maths to solve that. So to find the other fractions, I still need to solve the quadratic, I guess. So let's write the quadratic again. X squared minus 16x plus 64. Solve this. And it's an easy enough one to solve. We get two numbers multiplied to get 64. That could be 64 and 1. It could be 32 and 2. It could be 8 and 8. And 8 and 8 works well for 16 here. So it is 8 and 8. Let's see, minus 8 and minus 8 will get minus 16. And minus 8 and minus 8 will get plus 64. So there's your answer. The answer, well, there's the two other factors. So the other answer would be x is equal to 8. They gave us one of them. X is equal to 1. We found the other one. X is equal to 8. Let's see, is that what they asked for? Yes, find another value for x for which fx equals 0. X equals 8 is the answer. So part C asks us to use, it says in a strange way, use one of the values from part B. So you can choose 1 or 8. You can't really choose 1. We'll see why in a minute. And put them into the terms from part A, these terms here, and generate a geometric sequence. I'll need a bit of room, but basically if we put 1 in, we'd get 1, we'd get 5 minus 8 minus 3, and we'd get 9. We put these numbers, let me rub a lot of this out and I'll show you what I mean. So like I said, if we put 1 in, I think I said the numbers, we get 1, we get minus 3, and we get 9. This will continue on. We can see the pattern is 3's or minus 3's. So minus 27 and plus 81 and so on. Now I'm going to rub this out straight away because we're not going to use this. Because they want us to use it to get the sum to infinity. This has no sum to infinity. If or if the absolute value of or is bigger than, bigger than or equal to 1, there's no answer. Or usually we say if it's less than 1, there is an answer. Same thing though, I guess. And this is, or is minus 3. So the absolute value of minus 3 is too big. this will go off to infinity. Think of it, and you can see how, think of the last number if we continue on forever. It's massive. It goes towards infinity. And even worse, it has a plus and then a minus infinity. So it's a bit of a messy one. You could imagine they cancel each other out, but they don't in this case. They go out of control. We can't do it. So forget that one. Let's put in the number 8 into this series, and we'll see what happens. 8 squared is 64. 5 eighths minus 8 is 32. 8 plus 8 is 16. And we can see the pattern here. It's a half. A half, a half, a half. The next one will be 8. Then we'll have 4, 2, 1, a half. This stays going on a quarter. This stays going on forever and ever and ever. That's what the sum to infinity is. Now to answer this, it's actually really simple to answer, but I'm going to show you a little more complicated way. You know what, I'll show you the simple way and the complicated way. The reason I'm showing you the complicated way is I loved it. When I learned it in school, it blew my mind a bit. I was like, that was probably one of the things that opened me up to maths, where I was like, wow, that's amazing. So I'm definitely going to share it with you. The simple way first is just a formula from the book. Sum to infinity is equal A divided by 1 minus R. Fill in A is 64, R is a half. Fill it in, we get 128. You're finished. You'll get full marks on the exam. You'll also get full marks for my way, but it'll look a bit prettier. I'm going to draw some squares. Sometimes you'll see one. I'll draw 2 squares for this one. And I'm going to find the sum to all of this using a bit of logic. Or a bit of drawing, really, and guessing, perhaps. So we have, this square is 8 by 8, and I'll draw one more that's the same size. 8 by 8. Let me use a different colour to show this picture then. I'm going to show all of these numbers in a drawing. So 64 is easy to see. It's 8 by 8. It's the area of this square. So there we go. There's the first number, 64. Now let me show 32. Well, it's half of a square. So I have room over here to show it. There it is there. Now 16 is half of 32, or half of the square. So it's a quarter of the square. There it is there. Fill it in. 8 is half this size again, so we can fill it in here. 4 is half this size again. Fill it in. 2 is half the size again. Fill it in. 1 again, and this continues on. And you can see quite logically where this continues. Eventually, very soon, in fact, with this big marker, it will look like the entire square is full. It will never actually be fully full unless we go all the way to infinity. Then it will approach. It will become as good as full. As good as. That's what we're going to say in maths. So it's pretty much full. And you can see here, it'll never get any bigger than this. And this is very close to 128. I hope you agree. 8 squared plus another 8 squared is also equal to 128. And that's the sum to infinity. They don't always look this pretty. If R was 1/3, for example, I'd go ahead and use this formula. But when it's a half, oh, I love showing this because it just looks so nice. Okay, I hope you enjoyed me showing something that I enjoyed. I don't think I taught it as well as my teacher did, but what can you do? Thanks for watching. Have a great day.